Every single time Claude Code reads 15 different files just to track down one JWT validation service, it permanently trashes your finite main context window. And let's be real, spinning up a custom subagent for every little exploratory task usually just means burning a ton of tokens on YAML configuration that doesn't actually work. By the end of this explainer, you'll know exactly how to architect your Claude subagents to offload that heavy lifting, keeping your main context perfectly clean. But the part most tutorials skip, why you should never use this pattern for test runners, is coming up in a few minutes.
Right now, context bloat is the biggest constraint working developers face with AI tooling. Say you're exploring an unfamiliar codebase and need to know which service handles refunds. Without a subagent, Claude reads those 15 files, runs multiple grep searches, traces a bunch of function calls. All of those intermediate parsing steps get permanently stuffed into your main context window.
Yeah, and once that space fills up, Claude literally starts losing track of earlier parts of the conversation. You lose all visibility on the main thread because it's completely drowned in hundreds of lines of search logs you didn't even want to see.
The fix for this is offloading the exploratory burden entirely. We're going to isolate the search into a subagent so it returns only a clean, concise summary back to your main thread.
I'll hold you to that, but we definitely need to cover when to actively avoid this architecture too.
Let's dive into Section 1, Anatomy of a Subagent. Markdown and YAML. A custom subagent isn't some complex black box. It's literally just a markdown file with YAML front matter that you drop right into your project directory at .claude/agents/youragentname.md. Inside, you define a name, a single-line description, tool restrictions, and the execution model.
Let me pause you on the model selection, though. If I'm just running a basic file search across a repo, do I really want to burn expensive Opus tokens on that?
You absolutely shouldn't. For fast, lightweight code-based grepping, you set the model to Haiku. You only lock it to Opus or Sonnet for deep architectural analysis or complex code reviews. But here's the critical architectural detail that most developers completely miss. The description field isn't just a label to trigger the agent, it actively shapes the input prompt that the main agent writes to kick off the subagent.
Wait, so the main thread writes a prompt for the subagent based on that one string. If I just put a lazy label like code reviewer in the YAML, it's going to generate a completely generic kickoff prompt.
Exactly. With a generic description, the main thread tells the subagent something vague like, use getDiff to find the current changes. Then the subagent wastes time and tokens guessing which files actually matter. Anthropic's official documentation literally says you must tell the agent precisely which files you want it to review.
Okay, so by putting that strict instruction directly in the YAML description, we force the main thread to explicitly list the target files when it delegates the task. That stops the subagent from running blind.
Moving on to Section 2, Forcing Structured Outputs, Creating a Hard Stop. This is the single most important optimization you can make. If you don't lock this down, a subagent will wander forever, doing endless research and burning your token limits without returning anything useful. You fix this by putting a strict output format right in the body of the markdown file. Look at this exact 6-part checklist for a code reviewer. Summary, critical issues, major issues, minor issues, recommendations, and approval status.
Ah, I see. It creates a mechanical stopping condition. The subagent knows its execution is officially complete the second it fills in step 6. It structurally cannot keep rambling and bleeding tokens.
But I have a fundamental issue with isolating everything in a subagent. We fall straight into the loss of visibility trap. What happens when the subagent silently hits a nasty dependency error or figures out it needs a very specific bash flag to run a build script and then just discards all that intermediate work when the context window closes?
That is a very real problem. The main thread gets the final result, but if it needs to run a similar task later, it has to rediscover those exact same workarounds from scratch.
The fix is modifying that structured output we just talked about. You explicitly require an obstacles encountered section.
So we literally force the subagent to report setup issues, workarounds, or weird environment quirks back to the parent thread in its final summary.
Yes, if a command needed a special flag or a specific import caused a problem, that detail gets passed up. The main thread learns the environment quirks without having to read through 50 lines of failed bash logs. Section 3, Limiting Tool Access and Security Restrictions. Subagents shouldn't have the keys to the kingdom. If it's a reviewer, give it bash for getDiff, but absolutely block edit or write tools. You do not want it secretly refactoring production code in an isolated thread. But zooming out to the broader architectural level, how do you decide when to actually delegate a task versus keeping it in the main thread?
It has to be about the payload, right? What data do I actually need back to do my job? The defining decision rule from the docs boils down to a single question. Does the intermediate work matter?
If you just need the final result, like the exact file path of the JWT validation logic or a summary of a code review, you delegate it. You don't need the journey.
Makes sense for code reviews especially. If I just spend an hour writing a feature in the main thread, asking that same main thread to review it gives terrible feedback. It's biased by our conversation history. Passing it to an isolated reviewer subagent means it looks at the Git diff with completely fresh eyes.
Spot on. And you can push this separation even further with custom system prompts. Claude Code's default tone is very concise and code-focused. But if you make a copywriting subagent, you can instruct it on marketing tone. Or consider a styling subagent where you preload your specific design system files.
Oh, that's incredibly smart. The styling subagent automatically loads your project's color variables and spacing conventions into its isolated context before it writes a single line of CSS, completely overriding the default generic outputs.
Now for Section 4, Subagent Anti-Patterns. When subagents actually hurt your workflow. Okay, so where does this actually break down in production?
Remember that open loop about test runners from earlier? The Anthropic documentation states explicitly, testing has shown that the test runner pattern performed worse among all configurations.
It makes total sense. If my CI tests fail, I need the full stack trace and standard output to actually diagnose the issue. A subagent hiding the intermediate work completely hides the debug logs I desperately need. I just have to run the tests manually anyway. Precisely. So here is your strict avoid list. Number 1, expert personas. Adding prompts like, you are a Python expert, adds literally zero capability. The base model already has that knowledge. Number 2, test runners, which we just covered. And number 3, sequential pipelines.
Yeah, sequential pipelines are a massive trap. If you have one agent reproduce a bug, pass it to an agent to debug, and pass that to a third agent to fix, you lose way too much context during those handoffs. Bug fixes depend entirely on the discoveries from the previous step. Keep that in the main thread.
Keep the dependent steps together, exactly. So, to wrap this explainer up, if you're deploying custom subagents, here is your verifiable checklist. First, shape your kickoff prompts by writing highly specific instructions in your YAML descriptions.
Second, force structured outputs so the agent hits a mechanical stopping point and doesn't burn tokens running forever.
And third, explicitly require obstacle reporting in that output format so your main thread isn't left completely blind to environment quirks and dependency workarounds. If you follow these architectural rules, you will finally stop trashing your main context window with bloated search logs, and your coding sessions will run significantly longer and faster.
Right after this, open your project directory, navigate to .claude/agent/, and actually check your sub-agent markdown files. If your descriptions are vague, you are absolutely hitting context bloat. Go lock them down.
Because ultimately, you have to ask yourself, is your primary AI agent actually spending its tokens thinking about your architecture, or is it just drowning in terminal output?